In lesson 11.3, we talked about the area of a trapezoid. So remember, the area of a trapezoid is going to be equal to 1/2 the sum of the two bases times the height. We can also say the area of the trapezoid, or a trapezoid, is equal to the median, or m, times the height. And the median is just the segment that connects the midpoints of the legs. So if we take a look at the two equations for the area of a trapezoid, we notice that the median can be replaced for 1/2 of the sum of the two bases. So essentially the median is just the average of the bases. So in the first problem, we were asked to apply our knowledge by finding the area of the house. And we were given that the height of the house, which is 4 stories, is 24 units, and that each of the stories is going to be the same height. So dividing 4 into 24, we realize that the height of each story is going to be 6. So we mark up accordingly. And then looking at the triangle, knowing that these form right angles, we realize that we have, in the top story, a 3, 4, 5 triangle. Here's our 3 side, here's our 4 side, and then here's our 5 side. So we realize that this distance here is 8, and this is 8. We also know that this is 8 and this is 8. And we again, for the second story, draw another altitude. And because these lines here are parallel, the slopes of the house, the roof, are going to be congruent. So we know that these angles are congruent. And by the no-choice theorem, we know that these angles are congruent. So we have two similar triangles. And two similar triangles will have the same ratio between the sides of the triangle. So if this is 6 and this is 6, this has to be 10. If this is 6 and 8, this has to be 6 and 8 as well. And so based on our understanding of 3, 4, 5 triangles, we're able to piece together many of the parts of the house so we can find the area. So let's take the top 4 first. Let's find the area. It's going to be 1/2 of the base times height. We have 1/2 of 16, which is 8, times 6, which is 48. The third story is just going to be 16 times 6, or 96. The second story, we have the same rectangle of 96. And then we also have two smaller triangles that are the same as the two smaller triangles on the top floor, which equal 48. So we add another 48. And in the bottom rectangle, we have 8, 16, 24, 32 times 6, which gives us 192. And if you do the calculations, you should come out to 480 units as your units squared, as the area of this figure. Moving on to the next problem, we're asked to find the area of this trapezoid. Now again, when you see a 30-degree angle, it's a good bet that you're going to have to use the 30, 60, 90 relationships in order to solve the problem. So the first thing we're going to do in this problem is we're going to draw an altitude. Into the triangle to set up our 30, 60, 90 triangle. Altitude, remember, forms a right angle. I have a 30-degree side, and I have a 60-degree side. I know the 30-degree side is going to be half of the length of the hypotenuse, so I know that the height now is 6. And I know that this length here is 6√3. Now I'm going to drop another altitude. In this case, I'm going to raise it. And I'm going to bring it down to this corner of our trapezoid. I know this forms a right angle as well, by definition. And I know that that angle was 120 degrees, so I'm left with another 30-degree angle here. This is a right angle, so I have a 60-degree angle. Well, I know that this length here is 6, and that's the side opposite the 60-degree angle. And I know that the 30-degree angle is that value times √3. So I've got a value of 6 root 3 over 3, or 2 root 3 for this length, for this length here. So if this is 2 root 3, then this distance here is 3 root 3. And if this length here is 3 root 3, then I know this length here is 3 root 3. So I have the dimensions of the top, or one of the bases, and then this base, which is just the sum of those two values, which is 9 root 3. And I can figure out that the area of this trapezoid is going to be 1/2 of the sum of the two bases, 1/2 of 5 root 3 plus 9 root 3 times the height of 6. So I'm left with 7 root 3 half of 5 root 3 plus 7 root 3 is 9 root 3 is equal to 7 root 3 times 6 leaves us with 42 root 3 as your answer. Moving on to the next problem. We're asked to find the area of the trapezoid, and again we're looking at 30, 60, 90 triangles. We know that one of the bases is 12. We know that this angle is 30, and we know that one of the bases and the two legs are going to be congruent. Now, we also know, because the two legs are congruent, that we have an isosceles trapezoid. So let me just mark this up as two congruent angles. Well, we also have another isosceles triangle here, or an isosceles triangle, and we know that if the sides of this triangle are congruent, then the base angles are going to be congruent. So I mark this as 30 degrees. And I'm also left with 30 degrees here, because I know that I've got two parallel lines as bases for the trapezoid by definition, and I have a transversal, so alternate interior angles are congruent. That leaves me with a 60-degree angle here. I know that the hypotenuse is 12, which tells me that the side opposite the 30-degree angle is going to be half of that, or 6. And I know the side opposite the 60-degree angle is going to be 6 root 3. Because I know that the sides, or the legs, are the same as one of the bases, I also know that this base is going to be 6 as well. So the only thing left for me to do is to find the height of the trapezoid. And once again, I'm going to draw an altitude here, and I mark off my right angle. I have a 60-degree angle and a 30-degree angle, and I know that the side opposite the 30-degree angle is half of the hypotenuse, which is 3, which leaves me with 3 root 3 as my height. So now going back to the equation of my trapezoid, I have half of base 1 plus base 2 times the height, which is going to be 1/2 of 6 plus 12 times 3 root 3, which is going to be the same as 9 times 3 root 3, or 27. In the final problem, we're asked to find a formula for P and Q. Or I'm sorry, for segment PQ. So for this segment PQ. We're also given that X is the midpoint of AD, and Y is going to be the midpoint of BC. Well, I know that the median here is going to be half of base 1 plus base 2. So let me just create another document here so we can write this down. I know that XY, which is the median, is going to be equal to 1/2 of, I'll say, base 2 plus base 1. So by definition of the median, I know that x is the midpoint of AD, y is the midpoint of BC, xy is the median, so it's half of or equal to half of AB plus BC, or base 2 plus base 1. Well, I also know that P is the midpoint of DB, and I know that Q is the midpoint of AC. So by the midline theorem, I know that XP is going to be half of AB, and also QY is going to be half of AB, or B2 as well. So the midline theorem says that if you have a segment joining the midpoints of two sides of the triangle, then that segment is going to be half of the length of the third side, which in this case is going to be AB. So let me write that in here. I've got XP is half of B2, and QY is half of B2. So XP is equal to 1/2 of B2, and I know that QY is half of B2. Now, when I take a look at XY, I realize it's just the sum of certain segments, XP, PQ, and QY. So I can rewrite XY as XP plus PQ plus QY. XP plus PQ plus QY. And I know that those equal 1/2 base 2 plus base 1, because these three together are the same length as XY. And in fact, these three added together are XY. I also know that XP is equal to 1/2 B2, so I'm going to substitute 1/2 B2 for XP and 1/2 B2 for XY, and then I'm going to solve for PQ. And I'm going to distribute the half here. I have 1/2 B2 plus B1. I have 1/2 of B2 plus 1/2 of B2. That's 1 B2. So I'm going to subtract 1 B2 from both sides. And I'm left with PQ is equal to 1/2 B2 plus 1/2 B1 minus the 1 B2 that I brought from the left-hand side. I'll just say it's 1 B1. And this leaves me with PQ is equal to, sorry, this is B2, is equal to 1/2 of B1 minus 1/2 of B2.